Hi everyone. Okay. Can you please confirm if audio and video everything is fine? Okay. I hope everything is fine. So let's get started. Let me share my screen just a second. Okay. So everything is fine, right? Great. So let's start the discussion. So earlier the connection was interrupted, so that's why we were not able to complete the discussion. So let's now start it. So let's see this question. When the data is transmitted in a serial format. So by the way, we are discussing AIMT one, right? So let's directly see this question, which is question number 29. And this question was related to computer networks. Okay. So let's just see this. So they are saying, suppose that you receive this, okay, right? Suppose you receive this triple zero, and then one, then 10. Then see, these are the 4 bits and these are the 4 bits and then one. So let me write in this way: 0 0 0 1 1 0 1 0 0. Okay, suppose you receive this, and then they are saying that they are using even parity. So even parity means that total number of ones must be even, and this is a parity bit as they're specifying. Their parity bit followed by 8 data bits. So this is the parity bit, right? Parity bit. Now they are saying the total number of bits must be total number of ones must be even. But since you have received odd, so there is an error, right? There is definitely an error. Now they are asking that this error is where. Okay, see, the received code word is 0 0 0 1 1, right? And then 0 1 0 0. So this is something which you have already received, right? Now, since the number of ones here are the odd, right? Odd ones are there. It means error because you are using even parity. Okay, it means error. See, even parity means including the parity bit. Okay, there must be even number of ones. Now, just tell me that earlier, since in the sent code word earlier there must be even number of ones. Okay, so which means earlier, now there are odd number of ones, right? So basically you can say that either one of the one are increase or decrease. See, earlier earlier, let's suppose this is the case earlier, right? Okay. So I will be writing the earlier case. So basically here you can say maybe earlier this is one, right? Earlier this is one. I mean, one of the zero could be one, right? One of the zero could be one. Let me just take one of the zero. Let's suppose this, right? So it doesn't matter which one, but yes, one of the zero could be one. Okay. Right. So let's suppose this is the earlier. I mean, this is what you sent. Okay. Now, uh, so now that has been transmitted to zero. See, earlier you notice that number of the ones are even, right? So these are the 4 ones. So earlier the number of ones even. Now the number of ones are odd because this is what you have received. So basically, maybe this is the case that this one has been transmitted to zero. Okay. I mean, 1 to 0 is possible. This is also the case that earlier this was the zero, okay, and now this is one, right? I mean, this is also possible that 0 to 1 is also possible. So what I'm saying, that it is also possible that earlier you might be having something like this. Okay, so let me write. Maybe you might be having something like this. Okay, 0 uh 0 0 0 1 0 1 0 0. Okay, this is let's suppose sent. I mean, it might be also possible that one of the zero has been transmitted to one. Okay, I mean, maybe 0 to 1 or maybe 1 to 0, right? I mean, since total, see, in here also these are the even ones, there must be even ones. Okay, and here also there must be even ones, right? Because this is even parity and total number of ones should be even. Now received are odd ones. Received, in the received, you notice these are the odd ones, right? So basically maybe some zero has been transmitted to one, or maybe some one has been transmitted to zero. Basically, the thing here is that there are basically odd number of bits that has got changed. Okay, I mean currently I'm changing just one bit, but I will just show you with multiple bits also. But you cannot receive this, okay, with the even number of changes. See, there must be error, that is for sure. So that's why option is wrong. Okay, option is saying no errors, but there must be error. So that is why option is wrong. What about the next option? See, the next option is saying an even number of bits have been corrupted. Okay. So, do you think even number of bits? See, this is just one bit, right? And this is also just one bit. So, with one bit, we can get it. Can we get this with even number of bits? Okay. See, this is already odd, right? And this is even. So, basically, you have even ones here, even ones, and ultimately you want odd ones, which means here you have, let's suppose one two, I mean two ones. Okay, let's suppose, let's just keep everything zero, right? And here you want three ones or one one or something like this, right? Maybe one one. Okay, and everything else is to be zero. Okay, or maybe three ones. Okay, and everything else to be zero, something like this. So from here to here, if you want to go, then obviously you have to change, okay, odd number of ones. I mean, see, even are already there, then you have to change, I mean the number of flips must be odd, isn't it? Which means can it be the case that number of flips are even? See, if this one is changing from zero and zero changing to one, then there is no change. Ultimately, there is no change in number of ones. So this is not possible. I mean, ultimately we want some changes, right? I mean, from even we want odd. So basically, if some bits are basically canceling out their effect to each other, then ultimately it is basically, you can say, it is not the received code word. So, so ultimately, since we want odd, then it must be the case that we are changing the odd number of bits. Either this, either just one bit, or maybe multiple odd bits. Okay, maybe these three bits, or maybe these three bits. Okay, this one and these two. Okay, so basically, we must be changing odd number of bits to get odd number of ones. Okay, so you can say if you want to get odd number of ones, then you must be from even, then you must be changing odd number of bits. So that's why C is the correct answer. Okay. Okay, someone is saying, basically, I got some super chat. Let me, include that. Someone is saying, sir, I got 44 in AIMT. Can I get under 2K? why you are why you are aiming 2K? Okay, you can easily get top 100 or top 200, 300. See, I have already told multiple examples are there, where people have received, I mean, people have received the ranks like, in the AMT one, I think, we have already taken one session. In AMT one, Piyush, who has ultimately got AIR 1, right, in gate 2024, and in AMT 1 he has received only 52 or 53 marks. Okay, 52, 53, I don't remember exactly, but somewhere these around marks. If you know Hemant, okay, Hemant has already secured AIR 7 in gate 2025. So I think his AIMT 1 marks, AIMT 1 marks were, um, if I don't remember exactly, then the range I remember, it was around 40 to 42 or something. Okay, 40, 42 or 43. Okay, something like this. So don't worry about the AMT marks, right? I mean, there are many toppers who has done really very good after getting 40s around marks in AMT. It's not that in just 1 month you are going to improve from 44 to 80 or 70. See, you already have worth of 70 or 80. It is just that the complete summary is not with you. I mean, you have to revise, and there are like few practices that you have to do. But ultimately, you will be getting what you are worth for. Okay. Okay. Now let's just Okay, let's just go to the next this question. So option D is saying a bit transmitted as one has been changed to zero. No, it is possible that zero might has been changed to one. Okay, so zero might has been changed to one, or 1 might have changed to 0. It is not necessarily that only 0 is 0, or I mean, there need not to be any specific thing. Okay. So this is too specific. You can say this is too specific. Okay. Now let's see this question. This question was related to dynamic programming from algorithms. So what this question is saying is that suppose you have x1 to xn where xi is the non-negative weight. Okay, xi has the non-negative weight which is w of xi. You are required to select a subset of these items that no two selected items are adjacent. Which means if xi is selected, then xi minus 1 and xi plus 1 cannot be selected. Let Wi be the weight of maximum total weight that can be obtained by selecting x1 to xi. So basically they are saying that you are having x1, x2, xi, xi plus 1 and so on. Okay. Then you want to do the maximum total weight such that you cannot select two adjacent. And let's suppose they are saying that Wi is the maximum total weight till this point. Till this point. Now they are asking you what is the Wi plus 1. Okay. In terms of the Wi, can you tell me? See, in terms of the Wi, they want Wi plus 1. And Wi is the maximum total weight till this point. Okay. This is the like the almost same question, but that was the tougher question. In fact, Gate has already asked similar kind of question. Okay, I think I don't remember the recurrence relation that they had, but it was something like max of x comma y2 something like this. Okay, anyone remember that? There was some similar kind of question Gate has already asked, but it was actually a tough question. But here we are asking little easier version of that. Okay, see, uh, see, there are always two cases. Maybe you're taking this xi plus one, or maybe you're not taking this xi plus one. If you're taking this xi plus one, then obviously you cannot go for xi. I mean, you cannot basically take the adjacent. If you're not taking, okay, so if you're not taking, then you can take the xi. Is this okay to everyone? See, it is already written here that adjacents are not allowed. No two adjacents are allowed. Okay. So basically, let's just take two cases: take or don't take. Take this xi or don't take this xi. Okay. If you take this xi, then wi plus one will be, you can say, then you cannot. I mean, if you take this xi plus one, then you cannot take this xi. So that's why uh, the maximum weight will be based on wi minus one plus weight of, basically you can say, weight of xi plus 1. Okay, if you're taking this xi, then you can take this xi. It will add the value of weight of xi plus 1. But then you cannot take this. I mean, if you want to take this xi plus 1, then it will add this value. But then you cannot take this xi. So that's why wi minus 1. If you don't take, in that case, if you don't take, then you can directly take wi. Obviously you will be choosing whatever is the maximum between them, right? So whatever is the maximum, you will be choosing that. So you take or don't take, that's the question. Okay. So basically C seems to be the correct answer. If you take xi, then you have to go wi minus 1. If you don't take, then directly wi. Okay, so C is the correct answer. So by the way, this question I've taken from Stanford. Okay. So I've taken this question from Stanford, almost as it is I have taken. If you want, I can put the link under this question solution. Okay. If you really want it, you can comment it and I will put the link. Okay. Okay. Is this understood? See, in the dynamic programming problems, it is always the case that, okay, take, don't take. And then based on that, you can solve this question. Okay. So take, don't take, something like this you can do. And based on that, you can solve this question. Okay. Now let's see this question. This question was, again, this question was not hard. This was easy question only. So here they are saying that You are given a black box implementation of comparison based data structure that support the operation insert and extract min. It is known that data structure can be constructed on n elements in n log of log n time. So basically, building of the data structure is taking order of or theta of n log of log n time, right? A sorting algorithm is implemented using the black box as follows. Build the data structure of n elements. So basically it will take anyway n log n like this much time, right? Repeatedly perform extractment until all the elements are removed. So basically they want to take the minimum. Okay. So repeatedly means I think the total time will be here. The total time it will these two operations will take how much? Build will take this much. So build will take n log of log n plus repeatedly you are taking you are doing the extractment till n elements till all the elements are removed, and for each time it will take tn time, right? So this much. So basically the sorting time based on this data structure will be something like this. It will be theta of, or let me not write theta, that's fine, n log n plus n into tn, right? This is the sorting time. Now they're asking what is the minimum value of Tn. I mean, they are actually asking with the big omega notation. It means the minimum value of Tn, right? So what could be the minimum value of Tn? That's what they're asking. So what is the minimum value of Tn? See, ultimately sorting should be taking, okay? So whatever the sorting time, it should be taking at least n log n time, right? At least n log n time. Is this fine to everyone? At least n log n time they will be taking. Now, this tn, right? This tn should be taking at least log n time. If see this is already lesser than n log n, if this is also lesser than n log n, then obviously the both the quantities, I mean asymptotically both the quantities will be lesser than n log n, right? So tn should be at least log n, because we want see this is already lesser than n log n, so let's not even consider this, right? I mean we want this quantity to be n log n. If tn is also lesser than log n, okay, if this is also lesser than log n, which means if this quantity is lesser than n log n, then ultimately we won't be able to reach that bound, because this is the minimum time that any comparison based sorting algorithm takes. So tn should be at least log n, right? So tn should be at least log n, which means which means tn is equal to big omega of log n, which means it is greater than or equal to log n. Okay, is this understood to everyone? Great. Now let's just move to the next question. So here the option is correct. It was easy question, but still we made it 2 mark. Okay. See, this AIMT was we intentionally made it little easier. Okay, it was not tougher than gate level. It was definitely not tougher than gate level. Do you really think it was tougher than gate level? I mean, what else we will be doing, right? I mean, this was really easy question. Earlier was also easy question, so it was definitely not tougher than gate level. By the way, gate level is also not standard. I mean, gate also changes their level every time. So saying that gate level is very ambiguous term by itself, right? Gate gate doesn't have any predefined level that okay, this is the gate level, right? Okay, now let's just see this question. What they are saying. This is computer networks question. It was also very easy question, yeah, very easy question, and it was again 2 mark question. So see, if the question number is greater than 35, I think, or four, yeah, 35, then it is already 2 mark question. It was 2 mark question, and it was easy question. Okay, so what they are saying that just consider two end-to-end host. The size of the sender window is W bits, which means they are saying that you are basically sending W bits, right, over the C link bandwidth, which means you will be taking W by C time. So since you are sending W bits, so you will be taking W by C time, right? So here, uh, transmission time will be W by C. You can say transmission time will be W by C, right? Further, the round trip time representing here the time when the first bit of the segment is transmitted till the acknowledgement is received. So they are saying round trip time on the path between two hosts is RTT second. So basically, you start transmitting here, and let's suppose you're receiving here. Okay, I mean W by C time will be you will be taking to transmit, but RTT they are saying is basically the round trip time. So round trip time basically they are saying that it is getting started from here. See, round trip time generally have a little bit of I mean there are two interpretation of round trip time. Some people start from here, some authors start from here, but either this will be given in the question that they are starting from which place. Okay, I mean they are starting from here or they are starting from here. If they do not give, then the answer will not depend on the interpretation. Okay, so here anyway, just to avoid any ambiguity, we are starting from here. Okay, and it is given in the question that RTT is starting from here. So this is RTT. So in this time, in the RTT time, how much you are sending? You are sending W packets, right? I mean you are sending W bits. So they are asking throughput. So basically you can say the RTT is anyway greater than W by C. So basically you can say then RTT time. Okay, in RTT time we are sending how much W bits. So in 1 unit of time, this is the throughput, right? Throughput is basically, don't remember the formula. It is just in 1 unit of time how much you are sending. Okay, so in 1 unit of time you will be sending W by RTT, right? W by RTT. So I think B is the correct answer, right? W by RTT. This is the throughput. Understood? So this is W by C, and the RTT is basically greater than W by C. So that's why throughput is W by RTT. And I have also written that everything I think I've written here. It must remain. Hence the throughput. Hence during each RTT only W bits are delivered. Therefore the throughput is this, right? So throughput is basically the data we are sending in 1 unit of time. We are sending in 1 unit of time. Okay, great. Now let's see this question. So in this question, they are saying the TCP sender is sending 402. Okay, wants to transmit 402 KB file to the receiver that has already received the already established the TCP connection. At time T, the sender window congestion window is 2 KB. So they have already received. They have already established the connection. Now they are saying that congestion window is already 2 KB, and the slow start threshold is given, and sender is currently in the slow start. Okay, and the maximum segment size is also given. So basically the maximum segment size is 2 KB. So initially the sender will send 2 KB. Then it will just double it, right? It will just double it. So it will be next time it will send 4 KB. Next time it will send 8 KB. The next time it will send 16 KB. And till the point it is reaching the threshold, which is 64. So let me just show you that 2, 4, 8, 16, 34, and then 64, right? So now at this point in time, the threshold will reach. Okay, and I also have to add all of this. Okay, so basically if you add all of this, I mean till this moment, if you add, then 30 KB you have sent. Okay, and including this 32 KB, basically 62 KB you have sent, and including this, so basically if you add, or in other words if you add all of this, right, then you will be getting, I think, 126 KB. Okay, so till this moment you have already sent 126 KB, right? But after that, congestion avoidance will start because we have reached the slow start threshold. Okay, it is given that slow start threshold. So the notation is SSTHRESH. Okay, slow start threshold is given at 64 KB. So after this moment, can you tell me that what will happen? We will increase by 1 MSS, or in other words, we will increase by 2 KB. Okay, then you will send 64 KB, 66 KB, then 68 KB, then 70 KB, and then 72 KB, right? Then 72 KB and so on. But interestingly, here the catch is that they are saying the receiver window size is 70 KB, which means let me tell you that you will be sending. Okay, yeah, so basically you will be sending the data after this plus 2 plus 2 plus 2. But the moment you reach this, okay, then you will say that now the receiver window size is since 70 KB. So you will take the minimum of 72 KB and 70 KB, which is 70 KB, which means which means the congestion window is always, I mean, the final congestion window, or the final sender window, you can say. Okay, window is basically, sender window is minimum of congestion window and the receiver window. Okay, so here the congestion window is 72 kb, but the receiver window is just 70 kb, so that's why you will be just sending 70 kb. Okay, so see here, after that you will be, I mean, after this is 72 kb, but this is not what you will send. You will just send 70 kb, which means if you add 70, then in this round you will be just sending 70 kb, so it will be 400 kb, right? So the receiver, now always you will be see, always you will be sending 70 kb only, even though the congestion window is increasing, but it doesn't matter, because the receiver window is 70 kb. Now after this we will be sending 70 kb only. Okay, and then I think only 2 kb was left, so basically it will take 11 rtts to send total of 402 kb. Okay, the complete diagram I have already given in the solution, but now I think it is more clear, right? So basically you will be starting, the question is saying that you will be starting with the 2 kb, and then 4, then 6, then 8, and then ultimately 64 kb you will be sending. From here you will be sending 66 kb, and then in the next round you will be sending 68 kb, then 70 kb, and then it will be fixed. Okay, 70 kb only. So let me just tell you, till this 70 kb, till the first 70 kb, right? 68 and then 70. So till the this is 330. Okay, so basically till this point you have already sent 330 kb. Okay, till this point you have already sent 330 kb. Now you again want to send, okay, obviously the data. Then in that case you will not go to 72 kb, I mean, I'm writing the sender window. Okay, you will not go to 72 kb, you will again send 70 kb, right? Which means till this point you have sent 400 kb, and then 2 more kb you will send, right? 2 more kb you will send, then 402 kb. Understood? So that's how it will happen. Okay, so I think 70 kb will be sent, and then again 70 kb. So basically 2 times 70 kb, so 70 kb is one more here. So anyway, the total number of rtts are 11 rtt. Okay, 11 rtts. Okay, so someone is asking, Prashant Misra is asking some doubt here in the previous question. uh, Let me just take his doubt. So what he's saying, okay, yeah, so he's saying that in question number 39, TN is only time to extract min. When we ready-made black box data structure, then it should take the constant time. No, it is given, right? The no, TN is basically, we've read. I mean, no, ready-made data structure doesn't mean that extract min will take constant time. No, extract min or any other operation will take some time, right? Okay. So it's not like that extract min. I really wish that, okay, just the build is taking the time and nobody is taking any time. Suppose the extract min is taking order of one, right? Then then just take the case of heap. In case of heap, you take order of n to build, and if the extract min is taking just order of one, then n into extract min, right? N extract min. If this is just taking one time, then the total sorting will take n time only, right? Which is impossible. So order of n to build heap, and then n extract means, right? That's how you sort. So this is not possible, right? Because sorting should be taking n log n time, at least n log n time. Okay. Now let's see this question. In this question they are saying that that there are like three processes. X is the highest priority, y is the medium priority, and z is the lowest priority. And the processes can be in the running, ready, or blocked, or terminated, I mean these states. So now they are saying that there are no extra cpu bursts and all. Okay, step one, X start running, right? So X is in the running, so you can say X is in the running phase. X calls fork and Y is created. Since Y is just created, so it since it is a medium priority, so it will be in the ready state, right? So Y will be in the ready state. X is still running. The running process perform IO, which means it will be blocked. The running process X. Okay, running process is basically X here. Okay, the running process calls fork. Since now at this moment, since it is blocked, so this buy which was earlier in ready, it will be on in the running, right? And now it is calling fork and Z is created, and Z is basically now in the ready state because Z just got created. The earlier I request completes. Earlier I request means X is now ready, okay, and then obviously the running it will be immediately be in the running, right? Running, and now the running will be in the ready. The running process finishes the execution, so basically it is terminated, right? So X is terminated, and on after if X is terminated, then this will be again in the running. If X is terminated, then Y will be running and Z will be ready. So basically X is terminated, Y running, Z ready. A is the answer. Okay, understood. By the way, this question I've taken from Whisk University, as you can see from the top. This question I've taken from Whisk University. The exact same question I've taken, but yeah, it was a good question and it was, I think, a doable question. So the answer is A. Okay, which is a Terminator running ready. Answer is A. Okay, it was doable question, and this question I've taken from some university, which is Whisk University. Since they're asking, see in the question they're asking after step 6, okay, after step 6, which means after X is completing, then what will happen? Then obviously Y will be in the from ready, it will be again in the running, right? After this word is important. After step 6, understood? After step 6. Okay. See, do you think this was a tough question? How you can say that AIMT is above gate level? I will say that AIMT, this AIMT one was actually below gate level, right? Do you think it was above gate level? These were the easy questions. See this RTT question. This question, yeah, this was a little lengthy and it was a nice question to be honest. But apart from this, I think this question was easy, and earlier these questions were easy. 2 marks question was just like a cakewalk, right? I mean that's okay. You were not able to do it, but these exams are not above gate level for sure. Okay. Now let's just do my favorite question from this operating systems. Okay, and this question was really very nice, and I framed it, after taking a lot of time. So this question was, I think, the most favorite question among all the question in this AIMT, and let's just solve this question. So basically, they are saying they want to translate this virtual address, which is 5C5B, right? 5C 5B. They want to translate this virtual address to physical address. See, the important point here to note that they do not want the byte. They just want to translate to the physical address. Translate the following virtual address using the physical page content. So basically, they are just asking for the final physical address. They are not asking for the byte. Okay, they are just asking where is the final byte. Okay, I mean, they're not asking what is the byte. They are asking where is the byte. Okay, where is the byte? They are not asking what is that byte. Okay, this is important. They're not asking what is that byte. Now let's just solve this question. This basically, if you see, these are the 15 bits virtual address is given to you, and then if you do the address split, okay. So if you do the address split, then it will be 555. And based on this 5C 5B, if you do the addresses, this is by the way 16 bit. I mean, in the hexadecimal it is seeming like 16 bit, but you must ignore the first. It must be zero only. I mean, the MSB have to be zero because the virtual address is given to be the 15 bits only, right? So MSB will automatically be zero, but you don't forget to ignore it. Okay, so I just ignore it, and then ultimately you get that. Now this is the outermost index, this is the inner index, and this is the offset. Actually, all are, you can call all offset, right? I mean, this is offset, this is offset, this is offset. So offset to the, this is the offset to the outermost table, offset to outermost table, page table. By the way, this term offset, can I say this is offset? Can I say this is offset? Uh, is this a technically correct term? Yes, this is perfectly correct term, and in fact, this term I'm not saying this term. In fact, Gate recently, okay, asked some question, I think in 2022 or 23, and they have used the term offset for every level. Okay, they have explicitly written offset for this level, offset for this level, and offset for this level. For every level, they are using the term offset. Okay. You can check Gate 2023 or 22 question. Okay, Gate officially use the word offset for every level. Explicitly, they have written offset for this level, offset for this level, offset for this level. So we can say offset. Okay, everything is offset here. It is just telling that okay, you go to the outermost page table, and how much down you have to go. 23. Okay, you just be looking at the byte number 23. So by the way, the outermost page table is stored in the physical page 51. So basically, you go to the page 51 and go to the entry 23, which is D6. Now, this is the page table entry, okay, and then they have given the significance of page table entry. They are saying that each page table entry is one byte, the most significant bit is valid bit, and the remaining bits are telling you the physical frame number, which means from this D6, okay, from this D6, if you just a second. So if you just basically extract the bits, or if you just write this in the binary, then you will be getting something like this. Okay. Then first bit will tell whether it is valid or invalid. Okay. So it is valid. Now this page table entry is valid. And then this will tell you the physical frame number. So if you convert that to decimal, then it is coming out to be basically 86. Okay, 86. Which means they are saying, see, let me just tell you step by step. Probably, this is the important question. So I will be, telling everything very step by step. See, they are saying that you have these pages with you currently, and then these are your, this was your virtual address, and finally you got this, these are the indexes. So basically the virtual address, using the virtual address, you are getting this 23, right? So 23 means that this will tell you that how much down you should be going into the first page table. Now this is basically D6 is saying valid, and then 86. Okay, D6 is, you can say, valid 1 comma 86. I mean, you go to the page number 86. Basically it is saying you go to the page number 86. Now this will tell, which is 2, right? This will tell in page number 86 how much down you should be going. So how much down you should be going? You should be going to 2, right? You should be going down 2, something like this, right? This will tell you whether it is valid or invalid, right? So E7, let me just write E7. So see here, E7 is this, right? Which means it is saying valid. And then if you just convert, okay, the remaining part to be the decimal, the remaining part to be the decimal, it will come out to be 103. So basically it is saying it is valid, and then it is coming out to be 103. So it is basically saying that you go to the page number 103, okay? You go to the page number 103. Now, you can go to the page number 103. This is fine. And ultimately, see, you go to the page number 103, and then using the offset of 27, which is here, using the offset of 27, you go to 27 down, and then you will be getting the desired bit. Okay. So this is your desired byte. Okay. This is your byte that the CPU is asking for. But is the question asking for this byte? Tell me. Is the question asking for this byte? Question is not asking for this. Okay. See, the question is not asking for this. See, in the options, intentionally I made 1D or something. Okay. In the options, intentionally I made 1D or something. Okay. But the question is not asking for this, right? Question is asking for this 103. Tell me the page number, not exactly the page number, but in terms of the address, like I mean, not exactly the page number. Basically it is saying that tell me the physical address. Okay, final physical address. So basically what you have to do, if you remember, the virtual address can be split into offset. Okay, and the multiple labels. Okay, there could be multiple labels, and the physical address will be something like this. Offset will be heritage. Okay, this offset will be heritage, and this will be the physical frame number, which is coming out to be 103. Okay, this is the physical frame number, which is coming out to be 103. Is this fine to everyone? See, this D6 is basically the first bit. Okay, the first bit is basically the valid bit. And if you just ignore the first bit, and then the remaining, if you convert, okay, the remaining, if you convert, someone is asking how D6 is basically 86. The first bit is just telling whether it is valid or invalid. But the remaining, if you convert to the decimal, you will be getting 86. Okay, so which means this entry will tell you where to go. Okay, you go to the 86. This entry will tell where to go. You go to 103, right? I mean, the physical frame number is basically 103. So ultimately, for my byte, the physical frame number is 103, or in other words, right? In other words, in terms of the binary, this is my physical frame number. Okay, so this is my physical frame number, which is 103 actually. So the physical frame number I have to write as it is, which is 103, and offset I can copy from here because offset doesn't change, which is 11011, right? So offset is 11011. So offset I will copy as it is 11011, right? So basically this complete is what they're asking. Okay, so it is 1101, and then this one I'm writing this one, and then these three ones. So basically, right, and then this 1100. So this is your final physical address, right? This is your final physical address. If you convert that, what will you be getting? So see here, this is your final physical address. If you convert that to hexadecimal, then it is basically 8 plus 3, right? So this is 11. 11 is basically, see here, 0 1 2 3 till 9, it is fine. 10 is A, 11 is B, right? So 11 is B. So this is 11, which is B. This is 15, which is F, right? And this is 8 plus 4, this is 12, right? This is 12, which is C. Okay, so CFB. CFB is the correct answer. Is this fine to everyone? So I hope now you understood that how to solve this question. Do you want me to put a similar kind of question in the next AIMT? The similar kind of question for the better practice? Should we put similar kind of question in the next AIMT? Just let me know. Obviously with some trick, right? I mean, there must be some catch might be there which is different from this question, but yes, we can put. Okay, may not, I will not be putting in the immediate AIMT, but I will be putting in AIMT 3. Okay, may not be in AIMT 2 because AIMT 2 is almost finalized, so I will not be changing that. And let's just get a break from this pattern. I will be just putting some different pattern of multi-level paging in AIMT 2 if that is required, but in AIMT 3 we can again put some similar kind of pattern. Okay, great. Now let's solve this question. So in this question, they have given two threads and they have given two counting semaphores S and M. Now, if you notice this, this is basically, I mean, M is just bounded. Okay, I mean, if you want, you can even remove M, because M has to be one. If M is zero in any of the option, then there is no way to do anything. So basically, M is just redundant. Okay, which means what I mean to say that even if you remove m, then also you can solve this question, because m is not putting anything, m is not doing anything. Okay. They're getting my point why I'm removing, because m have to be anyway one, and this is just protecting this prints. So basically it will not impact this question if you even remove this m. Just for the sake of understanding, I'm saying. Okay. I mean, obviously m are already there, but if you want you can remove it. Okay, just for the sake of understanding. Okay. Now let's just see what they are saying. They are saying if initially s equal to 0, see m have to be 1 anyway, but if initially s equal to 0, so maybe let me just tell you, if initially s equal to 0, then every a must appear immediately after two printed b characters. See, if s is 0, then obviously you can't directly go through this, right? You have to basically increment this, okay, multiple times, and maybe let's suppose 2 3 times, 4 times. Since it is counting semaphore, you can increment it any number of times. Okay. But it is just like you can print two b's, okay, and then it will be s is 2 basically. After that s is 2, and then if you want you can print, okay, if you want you can go and you can print this a, which is fine. Okay, you can go and print this a. Basically, for every 2b, 1a is earned. Okay, 1a. You can say 1a, you are earning 1a. 1a is earned. If you want, you can print it immediately. But if you don't want, you can print b, one more b. Okay, you can obviously print one more b. Then s is 3. Uh, then you can print a. Okay, if you want, you can print. I mean, you can go through this and you can print a. So the moment you print a, then there will be two b's are you can say two b's are occupied. So basically, this will be decremented by 2. Okay. So basically, you can print this A even after 3 V's, but they are saying that every A must appear immediately after two printed B characters. So that's why A is wrong, right? So A is wrong here. Every A must appear immediately after two B's character. This is wrong. Okay. Now, what this question is saying, it is what this option is saying, that it is possible for A to appear before any B. Obviously, not possible, right? I mean, A cannot appear before B. I mean, you have to earn A. I mean, after for every two B there is one A. Okay, for every two B there is one A. If you want, you can print immediately. If you want, you can print it later. Okay. If S is 2, which means if S is 2, so which means, yeah, in that case, if S is 2, then you can basically print A. Okay. And then you have to again earn. Okay, you have to again earn from B. So if S is 2, it is possible for two consecutive B character to appear in the output. It is possible for two consecutive B characters. Yes, I mean, you can have it. I mean, you can basically have two consecutive Bs. If there is no harm in this, you can have. I mean, you can just run this twice, thrice, and then you can have it, right? Two consecutive B, you can have it. If S is 2 initially, then every A must appear after at least one printed B. No, A can even appear directly, right? A can even appear directly. I mean, they are saying every A must appear after B. No, A can even appear directly. In fact, the first A will appear directly, right? So they are saying every printed A must appear after at least one printed B. See, if they in this line, if they say except the first A, see, first A can appear, but after that, I think there will be a problem, right? I mean, we have to earn it. But first A can appear directly without any B's. So that's why this is false. Okay. So option C is true here. Understood? Sorry, this is basically typo. Option C is true here. Okay. Now let's solve this question. This question was related to perfect tree. So perfect tree has a fixed definition. This is perfect binary tree, which has a fixed definition. So perfect tree means that all levels are filled. Okay, all levels are filled. So if you have 7 nodes, then the tree will look like this. Okay. So using the in order, they are saying the tree is producing something like this, right? Tree is producing something like this. In order traversal is given to you. See, if it is perfect tree, I think the answer I have. Okay. If it is perfect tree, let me just tell you, then it will look like this, right? And if the in order traversal is given to you already, then can't we just say that, can't we say that you must be having 17 as a root? Because three nodes must be on the left, three nodes must be on the right. Okay, in order, three nodes, I mean, whatever the root node is, that three node must be on the left, three node must be on the right. So 17 is the root, that is fixed. See, in general, for any given for any general tree, if only in order is given, can you determine pre-order, post-order uniquely? Using only one of the order, can you determine other order uniquely? No, right? For a general tree. But since it is having a fixed structure, which is a perfect binary tree, right? It is having a fixed structure. That is why it is possible to infer the root. Okay. Now I can clearly say that root is 17. If the structure is not fixed, then how would I able to say that okay, three must be on the left, three nodes must be on the left, must be or left? I am saying because of the structure, right? If the structure is not given or structure is not fixed, then obviously you can't say something like this, right? So basically 17 is fixed to be the root, and then 837 will be here. Now from, since this is an order, so 3 must be again the root, okay? Because then 1 must be on the left, 1 must be on the right. So you can say 3 and then 8 and then 7. Similarly here, minus 1, 1 and 12. I mean, you can easily make the tree because of the structure. Okay. Is this fine to everyone? Is this fine? Let me know. Okay, someone is asking some doubt in the previous question. They are saying for option B, sir, in the question for option B, consider the string BBABB. BBABB. If initially as a 0, it is possible for A to appear before any B. A is not appearing before any to B, right? It is possible for A to appear before any B. See, A is appearing after two B's, right? I mean, you are checking these B's, but A is appearing after two B's. Okay. So maybe if there is any confusion, I will discuss this on the gate flow. Yes, maybe because of this language you might be confused, or I will just modify the language so that it is crystal clear. The language is crystal clear. Okay, so that there is no confusion. But as per this option, they are saying it is possible for A to appear before any B. Any B. So any B means like even before you print any B, you can print A. That's not possible, right? Yes, so NEB might be a little confusing. So basically, it is here like based on me, it is saying that even before you print NEB, okay, you can print A, which is not possible, right? Okay. Now this is solved. So now you can basically do the pre-order. Pre-order means root root, left and right. So root you can print 17, and left you will do then left 17. Then for the left there will be three nodes. For the right there will be three nodes. On left also root and then left and right. Right also root and then left and right. Okay. Great. Now let's solve this question. So in this question they are saying that what will be printed for this linked list. See here they are first printing the data, and then they are having the recursive call. So basically any function is doing this. Okay, let's suppose this is head. Any function is doing this. This is the first printing data. Let me write directly data, or maybe head data, doesn't matter. And then there is a recursive call. Let me go to the next page. Basically f is doing three things. First print, then do the recursive call on head data, right? I mean head next, basically it is going further, and then again print head data. Okay. So basically, this will again do the same job, right? Now let's just observe this clearly. So basically, what is happening? This is print head data. This will be head next, and then again this will be the print head data. Okay. So this is the kind of tree that you will be getting, right? Now, given that you have 1, 2, 3, 4, 5 as the linked list, right? So 1, 2, 3, 4, 5 you already have. Now one will get printed because of this. Then you will call the recursion. Then two will get printed. So basically you can see 1, 2, 3, 4, 5. I mean everything will get printed, right? Now, let's suppose you five got printed. I mean this is the fifth call, and I'm not drawing all the labels, but let's suppose this is the fifth call. Five get printed. In that case, it will be null, but the head data will be again five, right? Head data will be again five. And at that label, head data is again five, right? Now, if the four is get printed, okay, at that level, head data is again four only. Okay, that at that level, if this is four, then this is also four, right? So basically, it will, you can say it will first print in the forward way, and then it will print in the backward way, right? So 5, 4, 3, 2, 1. See, with by looking at this linked list, you can say that it will first print and then a recursive call, and at the so basically it is printing in two pass, the forward pass or backward pass. In the forward pass, it will print the linked list directly, but in the backward pass, it will print in the backward way, right, or in the reverse string. So basically, C is the correct answer. Understood? Okay. Yes, this was easy question. This was an easy question if you are good with the linked list. Basically, you are first doing this, which means the forward pass it will keep on printing, and while it is doing the backward pass, it will print in the reverse way. Because at that point in time, okay, whenever you are reversing, at that point in time, head data is not one. It is five, and just before that level, it was not three, two, or anything. It is four basically, and then head data is three, and then head data is two, right? Like that. Okay. So basically at every level, the head data is basically just same. I mean, it is not changing. So if it is four, this is also four. If it is, let's suppose, three, this is also three, right? So between two, three, between two, four, and then if this is five, then this is five. So kind of that. It is like symmetric. Understood? Now let's solve this question. This was a bit interesting question. So here they are saying you want 2D array 3 cross 5, right? Which means you want three rows. Okay, you want three rows and you want five columns. Maybe let me write like this. So you want some 2D array like this. Now they are saying that which of the following implementation of dynamic memory allocation can achieve this goal. So let's just check. So here they are saying A is a 2D array, no, I mean two-dimensional pointer or pointer to pointer, and it is basically pointing. So here let me just go step by step. In option A, they are saying that A is pointing to some memory. Okay, that memory is of size 3. I mean this is basically three cells. There in this memory there are three cells. Into three means three cells, and each can hold one pointer. Okay, each can hold one integer pointer, something like this. I mean A is pointing to some memory which is basically which can hold each of the cell can hold to some pointer, and then each of the cell they are saying that now this is pointing to the five size. Okay, the five size array, one dimensional arrow, five size of memory. It is pointing to five size of memory. It is pointing to five size of memory. Okay. So this is, this is about A. So is this behaving like 2D array, 3 cross 5 2D array? See, in 2D array, what is my expectation? Is my expectation like that A should be pointing to A should be pointing to the first row, right? I mean, in 2D array, basically, let's suppose I'm writing A, let's suppose in 2D array, okay? Let's suppose I'm writing A of 1, 2. Then what does this mean? Or in other words, I should be basically able to, the first index, right? First index should be going till, I mean, it is 0, 1, 2, right? First index can go till 2 and the second index can vary till 4, right? So can I do the same thing here? Yes, the first index can go to 0, 1, 2, right? And the second index within that, okay, once it is a0, then it is again a pointer. The second index can go to 0 to 4. So yes, this is achieving this goal. I mean, it will behave like a 2D array. But let's just see the other options. Maybe it is, better to analyze. But I think it was a MCQ question. But yeah, let's just see the other options also. So in the second option, it is doing the exact opposite. It is saying that A is now pointing to something of 5 cells. Okay, and each is basically pointing to three. Each is pointing to 3 cells, right? So is this achieving my goal? No. Why? Because now here A will not be the first index will or the second index will not be basically having you can say the not be able to range from 0 to 4. It will only ranging from 0 to 2. Okay, the second index, or in the first in this case the first index should be only ranging from 0 to 2, but here it is 0 to 4. I mean, the this is wrong. Okay, this is basically, you can say, 5 cross 3. Okay, this will create 5 cross 3. This will create, right? What about this? This is just that, okay, 15, okay, it won't be, behaving like a 2D array. It is saying A just pointing to 15 single cells. Okay, 15 single cells. So basically, you won't be able to index something like this. I mean, you won't be able to index something like this, right? I mean, you have to index just like 1D array. Okay, so it is just a 1D array. What about this? See, this is by syntax. It is saying age pointing to 3 cells, age pointing to 3 cells, but each is just integer. Okay, each is just integer. Each is just integer. Now, now you cannot ask this to hold. Okay, to the pointer. I mean, there might be the case that integer size and pointer size are different, right? So now you can ask this to hold to some pointer. So basically, this is because malloc will return the pointer, right? Malloc will return the pointer. So here, these are three the integers, but these has to be three the pointers. These three has to be the pointers, right? So that's why A is the correct answer. Okay. Now let's solve this question. They are saying which of the following statement are true. So here in this case, basically we are just having some properties. We are just permuting some rows. I think here, for example, these two rows got swapped. So basically A and C will be having determinant they are asking. So determinant of A. See here, I think A and B are just transpose of each other. Okay, A transpose is equal to B. So determinant doesn't change if you take the transpose. So that's why this is true. Okay, this is correct. Okay. What about C and D? See, D is very different. Actually, D is just to confuse you. Okay, these are the minuses in between. So D is very different. If you're confused, you can just take determinant of D. It will be, I don't remember the value, but it will be very different from determinant of C or determinant of A or something like this. Okay, D is exactly. I mean, D is very different matrix. It is, there is no property that is directly applying to D. It is very different matrix, right? So any option which is involving D is wrong actually. Okay, it is very different matrix. There is no property that directly apply to the diagonal of minus or something like that. Okay. So let's just check option C. So option C means they are asking about B and C. So see, A determinant and C determinant are basically related by the minus because I'm just swapping one. And B determinant, A determinant are same. So basically B and C determinant are related by the minus. Okay. So that's why A and C are the correct answers. Okay. See, you cannot take minus common or something. Okay. In the matrix, if you have to take the common, then it has to be multiplied by the all the numbers, not just some diagonal or some row or some column. Okay. That's how the matrix behave. So matrix into scalar multiplication means that you are multiplying with the everything. Okay, every number. Okay. Now let's solve this question. So in this question, they are saying that probability of A, B equal to true. I mean A equal to true, B equal to true is given to be something like this. And they are saying A and B are the independent variables. Okay. So since they're independent, so you can see from here, you can write like this. This is same as A equal to true into probability of B equal to true, right? Which is equal to 0.25. A equal to true is basically summation of these two. Why? Because of the total probability. I mean, A equal to true is basically B equal to true plus B equal to false, right? I mean, basically, let me write the rule. Probability of A equal to true is nothing but probability of A equal to true, comma B equal to true plus. This is called marginalization, right? Marginalization means you can inject any other variable, just like B or any other variable if you want. Okay. So basically, these two summation is probability of A equal to true, right? So which means these two summation is 0.6 basically. So 0.6 into probability of B equal to true means B equal to true. You can just take true. Yeah, you can just take these two, and which is basically 0.25 plus x. Okay, 0.25 plus x equal to 0.25. So if you solve this, x will come out to be 1 by 6. Okay, if you solve this, x will come out to be 1 by 6. And now we need to find by. Obviously, you can find by easily, like basically just by looking at this, I think. So a equal to false is x plus y. Yeah. So basically, a equal to true is 0.6. So a equal to false, probability of a equal to false is x plus y, and it should be 0.4 because a equal to true is 0.6, right? X is already given, so y you can find out from here. Y will be basically 7 by 30. Okay. So A is the correct answer. Okay. So A is the answer here. Understood. So basically, it was easy question, but I think these numbers are not very well suited. Probably later on, I will just change these numbers so that the calculation is easier. Okay. So maybe later on I will modify this just so that the calculation is easier. Otherwise, this question was easy. Not that much straightforward, but yes, it required bit of thought. But ultimately, it was doable. Okay. So that was all about this AMD solution. Now let's just let's just hope for best for AMD two. So we will be preparing very good questions for AMD two, and I really wish that all of you get very good marks based on your preparation in AMD two. AMD two going to be little I can say tougher than AMT one, or maybe I can say level up compared to AMT one, but it won't be that much hard. Okay, great. So let's just meet after AMT2. Okay. Thank you, everyone. Thank you so much. Just let me know if you have understood everything. Just comment it out and let me know. Thank you.